Welcome to the Subtel Forum wrap-up of SubOptic 2016. Wednesday was kicked off by keynote speaker Gerard Leonard, CEO of the Futures Agency. The futurists challenged preconceptions of near-to-future technologies, including the next steps in cloud computing, media delivery, and global communications. Directly after the keynote, an ICPC roundtable session made the case for cables. Presented by Dean Vaverka of Southern Cross, the discussion focused on the need for better visibility of the submarine cable space in other markets. Participants in the roundtable were Graham Evans of EGS, Nigel Irvine of Verizon, Keith Schofield of Pioneer Consulting, and Gary Waterworth of Alcatel Submarine Networks.
We've just had a really interesting session called The Case for Cables, and really looking at the legal and environmental framework and of course the role of the ICPC. I'm joined now by Keith Schofield and Dean Vaverka. Dean, you chaired that debate very much around the ICPC. Give me a summary of the growing role for the organisation.
The organisation's been around for almost 60 years and we've seen exponential growth in our role, primarily driven by the fact that governments need to be involved. It's a private government partnership that needs to evolve because governments really control our activities, and we underpin the internet and everything with our critical infrastructure, which is now being identified as critical infrastructure.
So it's effectively a campaigner, Keith, to enable cable operators, cable layers, these kind of submarine companies, of which you're all part, to actually get their job done, especially in tough regulatory environments.
Well, the ICPC has a tremendous opportunity at the moment to engage proactively with other seabed users. But actually we're very, very fortunate to be a community of interest, not just an industry association. So we have governments who are members of the International Cable Protection Committee, and so actually it's more than that. It's a forum to exchange views, to develop best practice, and to engage with other seabed users.
In the first session of the afternoon, Catherine Edwards of Vodafone chaired a discussion aimed at revealing the methods of managing system lifetime.
Today I would like to talk about recent experience of upgrading Hugo and how it might be applied as a model for future upgrades. And this is very much a system like a play in 3 acts. So, Act 1. Act 1 was the Gemini cable system, and it was built with 8 times 2.5 gigs in 1998. Act 2, it was redeployed as an unrepeated cable in 2006. And then in Act 3, it was re-engineered as a repeated cable again.
With me is Phil Lancaster from Vodafone. Very interesting project you were telling us about, the Hugo cable. Why did you have to re-engineer that, Phil?
Well, it lost optical margin, and because of knocks on the cable, and over time that had gradually reduced. So we cut into the cable and added optical repeaters, and that boosted our optical margin back up to allow a 100 gig upgrade.
And what was it before?
It was 40 times 10 gig before, but it was running right out of optical margin, so it reached pretty much the end of life.
But it's really, I suppose, a demonstration, an example of just how you can renovate an existing cable, an old cable, to give it a renewed lifespan, effectively, which is what this event was all about.
Yes. I mean, the cable started life in 1998 as the Gemini system, was redeployed as Hugo, and now it's got maybe another 25 years life. It's got plenty of optical margin. There's no reason to think it needs to be retired anytime soon. So
effectively you've renewed its life.
Renewed it, yes, that's correct, renewed it, yes.
Philip Lancaster, thanks very much.
So there's 3 different fundamental methods of reconfiguring and redeploying a retired cable. The first one is so onboard a cable ship at sea, in a depot or cable factory off-site, or inserting new repeaters on the seafloor, which is in situ.
Alan joins me now. Thank you very much for joining Submarine Telecoms Forum. Just give us an overview of the different types of redeployment, recycling as such.
So I looked at 3 different methods. The first one was at sea, where the cable is lifted by a cable ship and reconfigured on board the vessel, and then relayed in the same location or a different location. Off-site, which was taking the cable to a factory So that was for if there was more considerable reconfiguration required on the cable and less time constraint. And the third method was in situ, where you upgrade the wet plant on an existing system, so you don't need to lift any, or you don't need to remove the cable.
Right. And just lastly, in terms of recycling cable, is this a growth industry as such, or is cable now getting out of date and it effectively has to be abandoned and new cable put down?
So a lot of the older systems, the regenerative systems, the repeaters or the regenerators can't actually be upgraded, but a lot of the cable can. It's still suitable for newer systems, and these systems are retired or being retired. So there is a lot of cable under the sea that we can recycle and reuse.
And I suppose that's environmentally beneficial as well, isn't it?
Yes, especially in certain areas, the Mediterranean, for example, where there's a lot of cables. It frees up more space underwater as well as, because there's only certain routes you can take, and a lot of them are already taken, like all the prime locations are already taken, so it does free up more space as well.
Great. Alan Proudfoot, thank you very much.
After a brief recess for lunch, Elizabeth Riviera Hartling of Siena chaired a session that detailed aspects of network topology.
I'm joined now by Elizabeth Rivera Hartling, who has just moderated a very in-depth session, almost 2 hours long, but really, really interesting, very technical as well. But anyway, look, what I want to ask you about is really the changing trends in the landing architecture. It seems that that is changing. The traditional models are going away, and the new models of collapsing those different components is now coming forward. Tell me a little bit about that, and bear in mind that our audience is quite generalist, so try not to get too detailed.
Okay, I'll do my best. I think that it's a very good question, and it's actually probably summarizes the majority of the papers that were in the session quite well. I think that the overall theme is obviously around new cable builds and how that is changing the network architecture. So we had a paper discussing how open cables are being embraced in the industry and what that impact has on the network architecture at the landing station. We then had discussions about extending cable landing stations and the equipment terminal there into the POPs and into the data centers. And we also had conversations about how to take those new cables and the capacity that's enabled by those new cables, and how to share the costs of a new fiber pair across multiple cable owners.
Every 2.5 days, a submarine cable somewhere in the world gets broken on average. I'm going to explore the impact of this on the connectedness of the global society we live in. I'll look at some results based on actual fault data and conclude by looking at how we can improve layer 1 network topology to increase resilience.
Andy, thanks for joining us. Now, tell me, you've been crunching the numbers, and tell me what you've been doing. What have you been presenting here today?
Okay, well, it's something that's never been done before at SubOptic. In past years, there's been lots of detail about cable faults, repair times, but no one's ever actually said what impact does this have on the connectivity of the worldwide network of submarine cables. So I decided that I'd do my best, take the data, take all of the cable length data, fault data, repair time data, and see how that affects the availability of these major submarine cable arteries around the world.
Okay, great. And what kind of conclusions did you draw from all that data? Must have taken quite a long time, right?
Yeah, it did take a very long time. And in conclusion, I was able to find that places in Asia where you've got incredible threats from fishing, anchoring, earthquakes, underwater landslides, they need so many more routes to provide the equivalent level of resilience that you achieve in the Atlantic with, say, 3 crossings. So I was able to determine from the numbers that if you're going to invest in a cable network around the world of equal availability and equal resilience, exactly how many links you need. And in the Atlantic, that might be 3. In Asia, it could be between 6 and 8 diverse paths.
Spanning the afternoon into evening, the poster presentations and cocktail reception took center stage. Presenters from all walks of the industry have collaborated with colleagues and performed countless hours of research to provide nearly 40 posters this year. Topics included market and project trends and challenges, marine services and operations, network architecture and system design, equipment and component technologies, network operations and carrier services, and finally oil and gas and special markets.
Well, we're up in the poster room now, and we've got around about 40 posters here. As you can see, as you can hear, it's very, very noisy. Lots of people around having a drink or two. And with me is Christopher Barnes of the University of Victoria. Thank you very much for joining us, Christopher.
You're welcome.
Talk me through your poster. This is a rather unique idea, isn't it? And clearly one you've thought about a great deal, one you've fleshed out a lot. Give me a summary of what it's all about.
Yes, well, I'm doing this really as part of as chair of the United Nations Joint Task Force on smart cable systems that are addressing climate change and tsunami hazard. Right, so what we're talking about is utilizing the telecommunications cables that crisscross the world's oceans, and every 50 kilometers or so they have a repeater, right, which sort of controls the signal going through. So what we believe we can do, and the industry should do, is to add a set of sensors, just simple, 3, one for temperature, one for pressure, and one for acceleration. And we don't have the instrumentation down there, and yet we have cables with real-time ability to transmit data, crossing the oceans, crossing all the irregular features in the oceans, to which we can add sensors. Okay, it would add a little bit of cost, but they're not terribly expensive. They're very reliable. Right, we only started in 2012, and part of it is advocacy, trying to convince industry that they should do business differently.
We have Andrew Lloyd of Global Marine Systems Limited here. Thanks, Andrew, for joining us. Just talk me through your paper here. Brilliant poster. It sounds like a really specialised area.
It is indeed, yeah. So Global Marine is a leading offshore fibre optic cable installer. And this paper here is dealing with what we have to do to enter the 500 metre zone of a platform. So very basically, 500 metre zone is a safety area that they put around offshore structures to make sure that vessels are controlled going in and out of that 500 metre zone. So in order to do this, we have to go through a lot more project planning. So we have to identify permits of works for the platforms, any specialist procedures that we're going to have to invoke. If we have to put people onto the platform, they'll have to have specialist training. We'll have to schedule their movements. Getting people onto platforms normally involves helicopters, so we have to get the people there before our vessel's there. So everything's ready for us to work on that specific platform for that specific fibre installation.
Okay, it's a very specialised area,
Yep.
One which is similar to Nexon's, just around the corner in many ways,
yep.
But you're also a sort of fully operational cable installer as well.
That's correct, yes.
Tell me a little bit about that.
So Global Marine has numerous vessels around the world. Half of our business is maintenance, so we not only install the cables, but we look after them throughout their lifetime. And we have some very specialist tools. We have a deep burial tool called the injector, which can bury cables 13 metres below the seabed. 13, 1-3, to protect cables from big anchors from big ships.
Right, and how often on a route, what percentage of a route would that be used? I suppose it depends on the actual project, but on average.
It's very close to the shore, or if we're going through an anchorage, if the cable can't be routed around an anchorage, so approaching Hong Kong or Singapore, you just can't avoid it. So we bury the cable extremely deep in those locations, but we're talking about 1, maybe 2% of a cable route.
Right, so in very specific areas where those cables are under deep risk.
Become under a specific threat.
Right, okay, right, interesting. Andrew Lloyd, thank you very much.
Thank you very much.
Really interesting to talk to you. So we're going to take another wander up the other end of the room. Okay, well, we've got Lauren Berg of Sienna with us now. Lauren, perhaps you can talk us through this. I saw you downstairs in the last panel. And I have to say, this is where it gets complex, right? This is where it gets a bit difficult. So if you could just explain through your paper here.
Okay. Well, the whole concept behind this, I think, came out of the wireless industry, mobile phones, where spectrum is allocated for different purposes. And undersea cables is basically that. It provides an optical spectrum that can be exploited in certain ways. Now, with what we've got today, with the amount of capacity we can provide on a single fiber pair, for some customers that's more than they can consume. So the cable owners say, well, I can monetize this better, get a whole bunch of small customers, give them each a piece of spectrum, and charge them each a bit of money. But now you've got to kind of coordinate between different people putting...
Lots more work to do at that point, haven't you?
Yeah. There's different people putting light on, and they all have to play by certain rules because, as much as we like to think this is all digital, it's a very analog system, fiber optics. Traditionally, all of this has sort of been done on a gentleman's agreement, and it's been passively...
Carved up behind closed doors in smoke-filled rooms, right?
And agreed upon. But, 5 years go by, and what has been agreed upon, and there's no real hardware to prevent anybody misbehaving, right? Not that they do so intentionally, but mistakes are made, or confusion, communication, right? We're dealing with people. So what we're proposing, and all the hardware exists, it's just a question of how we bundle the software together, is you've got a spectrum controller and input police, where this box here will only allow, according to policy, a particular portion of the spectrum from a particular vendor, and it will only allow a certain amount of power from that vendor, okay? So this device will say, well, if you fail or if you're not playing by the rules, I can cut you out and put my own power management, local power management, surrogate wavelengths to just fill up that spectrum so that everyone else is kept whole. The key is all the hardware exists. Functionally, technically, it's not a challenge. It's how we do it and where it provides the most value.
Very, very interesting proposal. Many thanks for your detailed explanation, and yet a kind of a layman's explanation for us. But many thanks indeed. Okay. Appreciate it.
Thank you for watching, and be sure to tune in tomorrow for more SubOptic 2016 news. This presentation was brought to you by the SubOptic Conference. SubOptic, by the industry, for the industry.